All right, so today we're going to talk about factoring, but this time we're going to have some special cases. So they're special because there's a specific pattern that you guys will see, and they're also missing one of the pieces. So if you remember to factor, basically you're looking for two numbers that would multiply the first and the last number to get some number, and then you have to find two factors of that that would add together to equal the middle number. But the problem we see here is there's no middle number. So you could factor it and still do it the same way that we did before, where we use 0 as a number. Basically the two numbers would have to cancel out. So let's try that. First of all, before I start here, you notice like there's this really big number here. If I multiply that by 20, I'm going to get this ginormous number over here. So while that's certainly possible, there's something we can do to make our lives easier, and that's to factor out a number before we start. So if I look here, I have 125 and I have negative 20. So a common factor there, let's look at 20 first. 4 and 5 would multiply to get 20, right? So you could do 5 and 25 would also get to 125, right? 5 times 125, or by 25, would give you 125. So 5 would be probably the greatest common factor here. So we're going to just factor out 5 first. So 5 leaves me with 25, v to the second, and then minus 4. Okay? That's a little bit easier to work with. Now, this is going to be the long way of doing it. So I want to figure out what 25, well, let's do the long way. So 25 times negative 4 is going to be negative 100, right? So I want a number, or two number factors of negative 100 that'll add up to 0. Okay? So negative 100 is what it needs to equal, and I need two factors. Well, what can I multiply 10 or 100 by? Spoilers. 100 by, that would get to, or multiply to get to 100. Oh man, I'm just tripping all over my words today. So 10 times 10 gets to 100, right? But while I want them to get to 100 and it has to be negative, that means one has to be negative and one has to be positive. So if I plug those in, you'll notice they're going to cancel out when I plug them in if I were to combine them, which is perfect. That's kind of what I want. So let's try this again. 5, and then I'm going to plug in those two numbers. So 25v squared, and then we'll do let's do the positive 10 in this one. So plus 10v, and then minus 10v minus 4. Okay, and then I'm going to group them just like I've done before. Okay, there's technically another group here. That 5 is just going to stay outside because I pulled that out at the very beginning. So it's just going to stay outside for the remainder, and it'll just be outside. Okay, so let's look at the first one, and let's pull out common factors. So it looks like I can pull out a 5 and a v, right? So I have a 5 out front here, and then I have 5v, and then what's left is 5v plus 2. Okay, and then this next section I can pull out, that's a negative 10 there. It's inside the parentheses, we'll pretend. Negative 10 and a negative 4. Common factor there would just be negative 2, right? So minus 2, and that would leave me with 5v plus 2. Okay, so then I can factor these out. It's still going to go before the 5 here, so 5 in front, and then I have 5v minus 2 and 5v plus 2. Okay, and that's my factored form. That's my answer right there. Now, that wasn't too tough. That's pretty much what we've done, but there is a shortcut we can take today. And basically it comes down to this first part where after I factored out the 5, if I see something like this, which is the difference between two squares. If I think about that, 25 squared, or 25 has a square root of 5, right? V squared has a square root of V. 4 has a square root of 2. So each of those has a perfect square root, which means they're the square of something, right? So you kind of got to know whether or not something can be squared or square rooted today. But if you can figure that out, there is a pattern that we're going to be able to see. So let me show you those right over here. So the first pattern is what we just saw today. If I have perfect square in my first term, and that includes the coefficient. Coefficient needs to be perfect square. And then usually, every time, the variable in front is going to be a square of some kind, either to the second or to the fourth power. Okay? If I have that perfect square in the front and the second number is a perfect square and they're subtracting, so minus a perfect square, it's always going to become this. You're going to have a plus b, a minus b. Okay? So basically whatever the square root of b and a is, that's going to be what you're putting in here. Because if I just took the square root of 25v to the second, I would get 5v. If I took the square root of 2 or 4, I would get 2, right? And then I have plus and minus those. This would be like a, this would be like b, so a minus b, a plus b. That's what I got right here. So if you see the difference of two squares, you can automatically just, oh, it's that pattern right there. I know the answer to that. Easy cheesy. Okay, let's look at another example. Let me show you some other cases you're going to see. So other perfect square things you might see is in trinomial form. You might see something like this. A squared plus 2ab plus b squared. Okay? Now if you see that, so this is basically like 2 times whatever a and b are. Okay? If you see something like that, the pattern is just going to be this, a plus b squared. Okay? Or a plus b times a plus b. So that's all that's going to boil down to right there. So again, if you see that, that would be your a plus b squared. Other one you might see is if you have a squared minus 2ab plus b squared. This one is just going to be the subtraction squared. Okay? So again, easy to figure out. So if we look at this one, this is the difference of the two squares, and you get one of each, a plus and a minus. If everything's adding and is positive here, that is a plus squared. And if this is a negative, 2ab, that would be a minus squared. So let's look at an example of this. And let's start by looking at number 2 here. So number 2, first of all, let's figure out what a would be. A would be 5n, right? If I took the square root of 25n squared, that would be 5n. Okay, b would be 3, right? So if I take 5 and 3, and I multiply it together, I would get 15, right? If I times that by 2, I would get 30. Now, is this, so that would be 2AB. Is that going to be a plus or a minus? I've got a minus 30 here. So which one is it? It's this minus one here, right? So without doing anything, I can tell you that it is going to be this answer right here. 5n minus 3 times 5n minus 3. Or just 5n minus 3 squared. That's your answer right there. Or you could say 5n minus 3 squared. And that would also be an appropriate answer. Now I can go through here and figure this out real quick. But I mean, it shouldn't be too difficult if you think about it. I won't do the long steps. So that's just the quick way of doing it. You've got the shortcuts here right here. Let's look at a more complex one on the back. So here we've got things to the 4th power. And we're going to factor these by grouping just like normal. So I'm going to have to take the coefficient in front, multiply it by the last number to get what my two numbers need to be factors of. So let's try that. So 2 times a negative 18 is going to be negative 36, right? So I need two numbers that are a factor of negative 36 that add together to equal 9. So think about what goes into 36. First one that pops to mind is 9 times 4. That's not going to add up to 9, right? So one of them needs to be negative, one needs to be positive, right? Because it's a negative number. So 12 and 3 would equal negative 36. If I did 12 minus 3, I should get 9, right? So if I do negative 3 plus 12, that should equal, those are factors of negative 36, and it should equal 9. I don't know why I wrote negative 36 there. It should equal 9. Okay. So now I just need to split this up, and because this is x to the 4th and x squared, I'm splitting up the x squareds. So x to the 4th is still a perfect square, so we're just going to treat it just like we did before, except for when we split it, it would be, squared instead of just x. So let's look at this. So I have 2x to the 4th, and I'm going to put the plus 12 x squared here, and then minus 3x squared minus 18. Okay, now we're going to group them. So group. This first group looks like I have a common factor of 2 on the coefficients and x squared. So I'm going to take out a 2x squared. That leaves me with x squared plus 6. Okay. Second group looks like I have a common factor of a negative 3. So I'm going to take out it's plus negative 3. And that leaves me with an x squared and a plus 6. Hey, look, same coefficient or same binomial there, right? So I can factor that out, and I would get x squared plus 6 timesing by 2x squared minus 3. And that's my answer. Can't factor it any more than that. Okay? Now, if one of these had been like if this had been a 9 here, I could have done something or to do like the perfect square special case, right? And you are going to see that today. So let's do an example of that. Let's look at number 18. This one's kind of a beast. So if I were to factor by grouping, I would take 5 and I would multiply it by 315 to figure out what I need a factor of, right? That would be 1,575. That is a huge number. And that would take a long time to figure out the factors of. It would require a lot of plug and chugs, because I assume you guys don't know your factors of 1,575 off the top of your head. So there's something we can do to make this easier on ourselves, and it's basically what I did with the first problem. Is I'm going to look at these and see if there's a common number or factor here that I can take out to begin with to make these numbers a little bit smaller to begin with. And it looks like each of these has a factor of 5, right? So that should be easy to take out. So if I take out the 5 to begin with, that leaves me with an x to the 4th. And then 80 would be 16, so minus 16x squared. And then 315 would be 63. So plus 63. Okay, now, much easier, right? So let's start with finding our numbers, just so that we can split this middle number. So 1 times 63 would just be 63, right? So I need factors of 63 that add up to equal negative 16. So if it adds up to negative 16, that probably means that they're both negative, because it would have to be in order to be a positive number and multiply. So I think about 63. The only one that really pops to mind is 7 and 9. Negative 7 plus negative 9 would be negative 16. Okay, perfect. So negative 7 plus negative 9 would equal negative 16. Those are my two that I'm going to be plugging in here to factor out. So I'm going to put the 7 in front. So 5, again, just like the first problem, it's just going to stay there the whole time. It would be something I'd have to factor out at the end anyway. So it's where it needs to be already by taking it out at the beginning. So that leaves me with x to the 4th, and then I'm going to put minus 7x squared, and then minus 9x squared, and then plus 63. Okay, now I'm going to group these. Okay, now let's look at this first one. First one, we can take out an x squared, right? So I have 5 in front here, and then I've got x squared, and then I still have x squared minus 7. Okay, now this next one is a little trickier. I don't like this x being negative. So when I factor this out, I want to factor out the negative version of the number, which will end up making this negative. Okay, it's just like swapping negatives. Okay, it's like if you were to divide each of these by the negative 9, this would become positive, this would become negative. Okay, so that's basically what we're doing when we factor out, is we're taking away that factor. So if I take out the negative 9, that leaves me with an x squared and now a negative 7. Okay, so now that I've done that, I've got two of the same binomial here. I'm going to move it in front. So 5 times x squared minus 7 times x squared minus 9. Whew. And we're done, right? Wait a second here. There's something I can break down even more. If I look right here, I've got a squared number and the difference of a squared number. So if you remember back at the very start, if I have the difference between two squares, I can break it down even more to a plus b and a minus b. So I think of the square roots of these, it would be x and 3, right? So I can simplify this even more to be 5 times x squared minus 7, and then x minus 3, and x plus 3. And that is my final answer. So you're going to have to be a little bit careful today, and it's really just on these last problems. Some of these, when you simplify them, are going to have a special case hidden in there. They're generally pretty obvious, like a 9 or 25 or something like that. Something pretty obvious that you can see right away. Sorry for the long video, but it was kind of a lot.